Good afternoon, everyone. My name is Aniruddha, and I am the Global Solutions Manager for Healthcare Informatics Solutions. I'm representing Fujifilm. I'm based in Dubai. So first of all, thank you for the event organizers of PAS and for the evaluators for giving us this opportunity to present our AI solution. So today I will be presenting a few slides about the future of AI in diagnostic excellence and Fujifilm's role in that. So what Fujifilm and how Fujifilm perceives it and what products Fujifilm has brought in order to promote and to enhance the diagnostic excellence. So within Fujifilm, we believe that a patient's health doesn't just start with diagnosis and end with treatment. It is a continuously evolving cycle. And the same philosophy has been applied by Fujifilm in designing and engineering their products. So almost like 80, 90 years ago, Fujifilm had started off with films. So we used to supply films for X-rays and CT scanners. Then slowly we diversified and we developed imaging equipments and healthcare IT solutions. So as it stands today, we have a full gamut of products, right from X-ray machines till MRI, and we also have healthcare IT solutions to complement these products. So thereby we can provide the best healthcare services for patient care. Before we delve into AI, let us understand why there is a need of AI, first of all, in the healthcare industry, and what are the challenges because of which we are having AI applications in the whole continuum of the healthcare IT products. So as we know, the global population is increasing and aging. So are the diseases and the number of patients which are increasing. So it is becoming day by day very difficult for the healthcare to cope up with these challenges of growing patients and growing diseases. Also, there are initiatives like green initiatives, because of which all the vendors are trying to now move towards a paperless environment. So we are almost 99%, you can say, paperless in all the products that we give to our customers, and all this is for enhancing the patient care. So there is, and also the data varies from different geographies. So we have lots of data getting generated today, because there are the digital technologies are also evolving day by day. So today, if you see a CT scan, you can see almost like 10,000 images. So it is like the amount of data is now crossed the limit of big data, and there will be shortly an explosion of data. So we will have a lot of raw data with us, but it is of no use for us unless we interpret that data and we make it or convert it into some meaningful information. Only then we can analyze and we can predict and we can apply the correct diagnosis and correct tools to enhance the patient care. So that is the main objective. So we need something which can do this fast processing, which can do precise prediction. It can be an assistant for the doctors to be able to suggest the appropriate treatment for the patients. So also what has happened is, because of this increasing data, there is a growing pressure on the doctors, on the radiologists. Today, if you see, an average radiologist has to report almost like 50 to 100 studies in a day. So all this has actually necessitated for the advent of AI. So if you see, AI is playing a promising role nowadays in all aspects of the workflow. It is enhancing the workflows, it streamlines the workflow, it actually gives a direction and prediction for the functioning in the department. So that was one of the main reasons Fujifilm realized back in 2014 that the importance of AI. And we started developing, or embedding AI within our products. So if you see, in 2014, we actually started working on a platform for artificial intelligence. By its core competency, Fujifilm was always doing image processing, right from the past 80 years. So so post-processing is our core competency. We first of all developed an artificial intelligence module for post-processing. We have a product called as Synapse 3D, which is used for advanced visualization and post-processing of CT and MR data sets. And we have embedded AI applications within each of the clinical applications within the Synapse 3D. There are almost 55 clinical applications within the Synapse 3D. Each one of them is having a component of AI, which works on deep learning or machine learning. So any of the deep learning technologies are already embedded in it. Now, one thing is to launch a product. Second thing, like an AI, is to implement it on the field and make it working for the customer. Initially, when we had our first implementation, by the way, in 2017 in the UAE region, where we had introduced an AI for chest X-ray and for some of the other applications within radiology. And that time we faced a lot of resistance. Even like we used to do demos and presentations, and we used to face a lot of resistance even from the doctors, because they used to feel that AI is a replacement for the doctor itself. But then because we implemented the solution, it has been working now for the past 10 years in multiple sites. So the doctors have now realized also the importance of AI and to improve their efficiency in their day-to-day work. So we have an open AI platform or interface, which we call as Riley. Riley is a Japanese word, which means an intelligent thinker or AI. What does the Riley do basically? We integrate Fuji-developed AI algorithms, the native AI algorithms, and we also integrate the external AI algorithms. So there are about 30 AI algorithms with which we have integrated already. So we are actually heading towards a multimodal AI model. So we want a platform which can accept images, which can accept clinical data, like text data, and then we want that the data or the patient data should be analyzed from all aspects. So that is our objective, that is our final goal when we are developing the different AI modules. So also since we are manufacturing medical equipment like X-rays, like CT scanners, so we have embedded AI modules within these modalities as well. So today, if you see any Fuji modality, comes with an embedded AI. So when you take an X-ray, it goes to an AI module and it shows you the lesions on the chest X-ray, for example, and sends back the result, to the modality console. So this is just a small example. We have information systems like RIS, PACS, vendor neutral archives, where we have integrated the AI modules, different AI modules. So this is a small video which is showing you
the best image processing technologies over the past
AI
70
journey.
years.
So Fujifilm has developed
Our image
basically,
processing technology
it does the
has been used by
post-processing
many medical institutions.
of the CT and MR data
Today,
sets.
we provide
As you
over
can see,
70
whenever
recognition
any image
technologies for
enters
medical
into the
imaging,
system,
which are
first
now
of all,
used in clinical situations
it detects
worldwide.
the organ. The AI detects the organ.
In recent
it does a
years,
segmentation
artificial intelligence
of the data,
technology is
and the
exponentially
respective
improving
data
its
is being sent to the
performance.
specialties, because there is a specialty-based reporting followed in many
Fujifilm will
hospitals.
offer to improve
So,
the workflow.
The Fujifilm AI is
Leveraging
called
a
as
combination
Riley.
of the latest AI
So
technology
what we are
with
doing
our
is
image
we are
processing
leveraging the
heritage.
combination of the latest AI technology.
This is the
with
future
our,
diagnostic workflow
with our
we
image
offer to
processing.
realize with Fujifilm AI. For example, the AI
So as you
starts
can see,
immediately
the AI
after
starts
the imaging
immediately
exam.
after the
It
imaging
recognizes
exam.
the body
It
parts of
recognizes
the
the body
imaging
parts,
study and scans for
like
differences
the
from
images
normal
are coming
structure.
from brain or
Among
from
detected
lung or liver
features,
or
it
heart.
triages patients and delivers a
Once
notification to the
it
best-suited
detects it,
radiologist in
it
the
does
appropriate...
actually a triaging. So based on the findings of the AI, the work list is being prioritized for the doctor. So the studies which are having the maximum findings
are annotated to be easily recognized. AI also lists out the potential conditions of disease from its database so that the radiologist can effectively do the diagnosis. Fujifilm offers an open platform to realize the new diagnostic procedures. Many AI modules from various developers as well as Fujifilm's AI modules can work on the open platform. AI from various sources work in concert to provide maximum value for the delivery of healthcare. Start a revolution with Fujifilm's AI.
So we call this platform as Riley. As you can see here in this block diagram on the top, these are all the information systems of Fuji, which includes the RIS, the PACS, the cardiology management, information management system. It can be a dictation system, it can be a dose management system. So this is the top layer, which is actually a layer of data source. The data from this layer is being sent to the respective AI modules, which is the third layer, as you can see at the bottom. So the third layer is the Fujifilm developed AIs, which we call as native AI, and the external AI algorithms. So all the data is being sent to the respective AI algorithms. The AI will process the data and will send back the results. And all this communication happens between this, through this platform, which we call as Riley. And the main thing is the Riley is an open interface, which can talk to both the modalities, our risk packs on one end, and with the AI algorithms on the other end. And the results are then populated in the respective source systems, which are like the PACS or the RIS or the cardiology system. And even the work list is being triaged. So I will explain the more details in the following slides. So we not only deal with DICOM data, we also deal with non-DICOM data. So today you have, let's say, an ophthalmology exam or a photo. And we have an AI algorithm for that. So the ophthalmology image or photo can be sent to the AI algorithm, and the results can be again sent back to the source system, from where an impression can be made, a report can be created by the doctor. So the way we work is, since we have introduced AI in all our products, it has slightly revised the workflow in the radiology department. So the first thing that happens is the work list prioritization. So based on the number of findings that the AI has found and sent back to the PACS, the work list has been prioritized. So the studies which are having significant number of findings will be on the top. So it's sort of a priority work list for the radiologist to start reading, because he might have hundreds of cases. So he wants to know which is the most urgent case to be read. And then it goes below in the sequence of priority. The second thing, what the AI does is, once it has identified the particular organ, then it starts detection of the lesion. So the second step is detection of the lesion and quantification of the lesion. So the doctor can actually do some manual measurements, some automatic measurements using the AI, and these manual and automatic measurements are then populated in a report, in a structured report, as you can see. So this structured report is again a semi-automatic process. Some measurements have to be done, and then they get populated in the report. Some measurements are automatically done and they get populated in the report. So at the end of the study read exercise, the doctor has got a structured report with key images and with the impression. And then he can add on any addendum comments to that report. And this report can be then published in a digital format. So it can go back to the PACS system, it can get distributed within the hospital. Also, this reports and this data is used for teaching purposes. So if you have a university hospital, this data can go to the teaching archive for teaching the residents or for teaching the students. This data also can be anonymized within the system, and it can be shared with research institutes. So it can go as an input for developing their AI modules. So we follow this workflow, and it's a standardized workflow. Irrespective of the AI algorithm that we integrate with, we are following the same workflow. So there is no change as such for the doctors. It is basically a seamless approach of integration. This is a second example where we are showing, for example, we have a CT study. Based on the data, the AI will first of all detect from which organ the data has come. Okay, and Fujifilm, by its policy, we don't want to radiate the patients. We know that the patients undergo many examinations within the radiology department. So what we do is we also have an AI for image processing. We apply low dose CT, and the image is, as you know, for a low dose CT, the image will be more noisy. There will be a lot of grains in that. So the AI module will actually reduce the noise. It will enhance the image. So at a very low dose also, we are able to get an image which is equivalent to a high dose image. And then this image is then, the lesions are detected, the CAD markings are done, the quantification is done, lesion measurement is done, and all the measurement results are then populated in a structured report like this, along with the key images. So the key images and the report are available for the doctor instantly once the exam is completed. And then he can do even further post-processing because we have a 3D reconstruction also available along with the AI. Okay. And within the 3D reconstruction, again we have AI modules embedded in order to speed up the reporting process. This is actually a list of AI algorithms. Some of them are native, some of them, the others are all external AI algorithms with which we have integrated till now. So there are almost 30 plus algorithms with which we have integrated, and most of them are like FDA or CE certified. So that is why we are enhancing or developing our AI interface so that we are marching towards a multimodal AI. So we want not only image data, we want all kinds of data to come into the AI, and then the doctor can have a holistic view of the patient's health record, you can say. So to summarize the clinical benefits of AI, and Synapse is the Fuji brand name for their healthcare IT solutions. So we can get maximum efficiency because it is integrated into the existing workflow. There is no change management effect, irrespective of the number of AI vendors that we are adding. There is standardization in everything. The doctor can still continue to read his cases as he was doing prior to implementing the AI. It supports pre-read notifications like triaging, like worklist prioritization. It supports post-read overview. So doctor can have incidental findings once the data is processed using AI. And there can be precision of diagnosis. So overall, it will enhance the productivity and the efficiency of the radiologist while he's reporting. We can keep on adding multiple AIs, as I said, as we are moving towards the multimodal approach for AI. Now we come to a case study. This is called as an AI revolution. So what Fuji did in 2018, as you know, the Japanese people, their average life expectancy is 85 plus, maybe around 85 to 90. There is a place in Japan called Okinawa where there are old people, like 90 plus. Some of them are even 100. So 90, 100, 105. Most of the people staying in this place are having a very high life expectancy. So what is the reason for that? So the Japanese joyful longevity, as they say, is created by a preventive culture. Simple thing, prevention is better than cure. So what the Japanese have done is, each person, each individual has to do an health checkup. He has to do a screening on a yearly level, on a yearly basis. This is mandatory. And the results of the screening, and you will not believe this, the results of the screening will be like a scorecard, like the one which we get in a school, like A, B, C, D. Okay? And the more C and D a person has, that means he is not healthy, he is sick, he is not promoted, he is not appraised properly in the company. So it's linked to his corporate career growth. And they follow it very seriously. So Fuji wanted to bring this concept to the rest of the world. So what we did was we identified a densely populated country, let's say India. And then we did a study on what are the major factors that affect the longevity of the person. Okay? We found that today the two major killers, first one is the heart disease. Second one was neuro and stroke till a couple of years ago. But now the number two is cancer. Okay? So heart diseases and cancers are growing day by day. Okay? And most of them are like, there are various factors responsible for them. So we are not getting into those details. Oh, sorry.
Any questions for our speaker?
Sorry. Can I? Yeah, I have 3 more slides. Yes. Yeah, please. Yes, surely. So based on the study, what we have done or what Fuji has done is, we have launched a screening center, okay, which Fuji operates by its own. We call it as Noora. What happens in the screening center is it looks like a health spa. We don't want to give it a feeling of a typical medical or imaging center. So any healthy customer who walks into the screening center will undergo around 30 tests, in the screening center. And these tests are related to lifestyle diseases and cancer. So we have screening tests for lifestyle diseases and for cancer. And based on this test, we conduct them yearly. We give a report card to the patient or to the customer, similar to what I explained before. And this concept of screening, we are now spreading globally. So we have a couple of centers in India, we have in South Asia. We are starting the first screening center here in Abu Dhabi in the next 2 months. So it will be the same concept. So that's about the AI revolution that Fuji is thinking about. Thank you.